Hello, you absolute legend. In the Chemical Equilibrium Lab, Part B, this is what your goals are. You are going to create 5 solutions. You are going to use the spectrophotometer instrument to measure the absorbance of those 5 solutions at 450 nanometers, the same wavelength we use for our calibration plot. And then using your calibration plot from Part A, you'll determine the molarity of the iron thiocyanate from the 5 solutions you made. The 5 solutions are described with their volumes. Now the molarities listed here, make sure that the ones on the bottles are the molarities you use. The calibration plot for Part A has molarity of iron thiocyanate on the x-axis, and for the equilibrium expression, this is the molarity of the numerator. From your 5 solutions in Part B, you will be able to determine the molarity of the iron thiocyanate, the rusted red molecule that is in the numerator of our equilibrium expression. You will have 5 of these set up, 1 for each solution. The numerator is Part B. The denominator, you will use a Rice table to determine the molarities to plug into here. For calculating capital K, we need to know the equilibrium concentrations of our reactants and products. A Rice table is a way to organize your thoughts. Please pay close attention. Reaction, initial molarity, the change in molarity, and the equilibrium molarity, the equilibrium at the end of the day. These are the final numbers we want to plug into the capital K in the numerator and the denominator respectively. This number was determined from the calibration plot in Part B, and you are doing this 5 times for each of your 5 solutions. Let's start at the reaction. The balanced chemical reaction needs to be written up here. Whether there are 1s in here or not, you need to make sure. The initial concentrations, you know these initial concentrations because you made the solutions. Now remember, concentrations are moles per liter. Moles per liter. Moles per liter. Now, not a trick question. At the initial time 0 of the reaction, we have 0 moles per liter of our product. Our product is not at any time to produce, so it is starting at 0 molarity. It is going to increase over time, so we put a plus sign. Our initial molarities you can calculate. You will calculate the moles of this number and the total volume. You can calculate the moles of this molecule and the total volume. These are numbers you must calculate. You will not pull them directly from this table. The reactants, there are 3 qualities of this change line that I want you to understand. The first quality is whether it has a plus or minus sign. The reactants are meant to go down, the products are meant to go up. There is our logical assumption for the plus and minus sign. The coefficient, how much will it go down? With respect to the balanced chemical reaction, it will go down 1 equivalent. This will go down based on the balanced chemical reaction. This will increase based on the balanced chemical reaction. And it will increase, so this will decrease a coefficient of some value x. 3 qualities in this line. 3 qualities in this line. Now we have an equation for our equilibrium line. We have a number minus 1x is going to equal something you will calculate. A number minus 1x is something you can calculate. Here we have a solved equation. 0 plus 1x equals this number you got in part B. This is an equation you solve for x. Solve for x. Remember, all we want are these red boxes. So once you solve for x, you can put that in here. And now you can solve for all three of these boxes. I hope this helps. Thank you.